Today we are exploring Apache's PIGS data model and architecture, which is essential for mastering big data processing. Whether you are a student, a tech enthusiast, or a professional, understanding PIG is crucial for anyone dealing with large data sets. Join us as we simplify complex concepts. Like, subscribe, and hit the bell to dive into PIG's world. PIG. Here PIG stands for Processing Intelligently on Grids. PIG is a high-level scripting platform developed to simplify process of working with Apache Hadoop. It allows developers to write a complex data processing task using a script language called PIG Latin. PIG abstracts the complexities of Hadoop, making it easier to develop data processing application without dwelling into the intricacies of low-level MapReduce programming. So here let's see PIG's data model. In PIG, the data model is based on atomic values and complex values. Under atomic values there are four types: integers, floats, and strings. And under complex types there are tuples, bags, and maps. Here tuples are ordered set of fields. So here each field can be any one of the data type, like tuple, bag, or map. But under map, it is an unordered collections of tuples. So bag can contain tuples of different schemas. Maps. Here map is similar to dictionary in Python. So it is a collection of key value pairs. Keys and values can be of any data type, including other maps, bags, type, tuples, or atomic values. Let's see PIG architecture. The PIG architecture comprised of the following components. PIG Latin scripts. Basically, it is a high-level program written in PIG Latin. So it is a scripting language specifically designed for PIG. Users can define series of data transformation using PIG Latin. Next comes the grunt shell. So it is an interactive shell where you can enter PIG Latin commands directly. Imagine it as a sandbox where you can play around with PIG commands before finalizing your script. Then PIG server. So it is a component that allows you to submit PIG scripts for execution. Imagine it as a coordinator that takes your finalized script, ensures it runs on the Hadoop cluster efficiently. Then comes parser. It checks the PIG scripts for errors and structure. It ensures that the script makes sense and translates it into a graph-like structure. Think of it as a proofreader for PIG scripts. Then optimizer. Obviously, it optimizes the scripts and optimizes the graph. It streamlines the operation for efficiency, making the script faster. Imagine it as a planner arranging tasks to save time and effort. Then compiler. It translates the optimized plan into language that Hadoop understands. It turns the optimized plan into a set of instructions Hadoop can execute. Think of it as translating a refined plan into a language that computer can follow. Then execution engine. It runs the translated plan on Hadoop. Imagine it as a manager overseeing the team's work to produce the desired outcome. Then MapReduce. It is a programming model used to process large dataset in parallel across a Hadoop cluster. PIG server translates the PIG Latin scripts into a series of MapReduce jobs, which are then executed on the Hadoop cluster. MapReduce enable distributed processing across clustered nodes. It breaks the task into smaller parts and process them in parallel. Then HDFS, Hadoop Distributed File System. A distributed file system that can store data across multiple machines, providing high fault tolerance and scalability. Input data from HDFS is processed through PIG Latin scripts and MapReduce jobs. PIG, PIG scripts data, PIG scripts read data from HDFS, process it using MapReduce, and stores the result back into HDFS. So all this about PIG architecture and data model. Let's see an example in Pig Latin script. Now load the data in the input data text file, treating it as a comma separated file, and it names the columns as name and age. Now filter the loaded data to keep only the records where age is greater than 30. Now store the data in output data directory. After running the script, the output will be stored in output data directory. The output data will contain the records of people with an age greater than 30 from the input data. Now see this example. Alice, Bob, Charlie, Dave, Eva. Among them, Bob and Dave are above 30. So the data will be stored in output data directory. Happy learnings!